my channel Engineering Campus of Plant Design. So as we were continuing with the pressure vessel design as per ASME section at Division 1. So here we are going into the part 2 of this video. So in part 2 we are going to mainly concentrate into welding inspections, because before I go into design, because there are some factors which is called efficiency of the weld. So the designer must know what are the efficiency based on the radiography test. So radiography test is mandatory as per ASME section division 1, and it can be exempted also as per the client requirement. So there is the option for both, but in both the cases, what will happen is your design efficiency will increase or decrease depending upon what category of radiography you have considered. Okay, let us quickly go into the radiography. Before we go into radiography, you must know different type of weld joints. So if you go figure UW3 in ASME section division 1, if you remember, I have said the ASME is into three main categories: U general, UW, and UHX, right? So UW3, if you see, there is a figure which is UW3, and in UW3 it has divided into different types of weld joints. So type A, this different categories, not type. This category of weld joint, we will see type of weld joint later. So this is category of weld joint. Okay. So depending upon the location of the weld, the category of the weld is defined. For example, now if it's a shell with the head, okay, so this will be category A. And if it is with the head inside, for example, now you have a big diameter vessel, and you need to join two plates together. So what will happen is that joint will become as a category A weld. Okay, and the long seam is also a category A, and between two shell 1 and shell 2, that will become category B. Okay, and now category C, category C is if you have a flange. Okay, the flange with the even if it is nozzle, or if you see here, it's a body flange. The body flange with the shell is also called category C. This is category C. Any fillet weld with the flange is a category C joint. Okay, and category D, the nozzle alignment, nozzle attachment is category D. This is category D. This is category D. Okay, so these are the main categories of the uh, weld joints. Okay, so let's move on different types of weld. Different types of weld, we have type 1, type 2, type 3, type 4, type 5, type 6, type different 6 type of welding in a pressure vessel. Okay, so what is type 1? So depending upon type of welding, and so what happens is the efficiency goes higher or lower. Even if you do any radiography, in some of the welds there is no efficiency at all. Okay, so designer must be very specific in giving type of welding. And normally if it's a pressure vessel with with high pressure or low pressure, we always go with the type 1 welding. Why? Because wherever there's a bed joint, you always go with type 1 welding. And the radiography is already done in the butt joints. It cannot be done on the fillets or the on the nozzle with the it only butt joint. Wherever the butt joint is there, we do radiography. Okay, so type 1. So type 1, what happens is you do welding from here. Okay, and in the bottom you back chip. Sometimes you put the back strip and you remove the back strip, you back chip it and you weld it again, weld again. This is the most commonly used type of welding in pressure vessel fabrication in manufacturing process. Type 1 welding, type 1 weld. And the inspection efficiency is also higher for full radiography, spot radiography, not inspected, which is no radiography. This is different types of efficiencies depending upon the types of welding. Type 1 welding. So type 2. So in type 2, what happened? You have butt joint, but you put back strip. But in type 2, it is not required to remove a back strip. Okay, you can put back strip in place after welding, and no need to remove it. Okay, and in some circumferential joint, what happened? There's a special machine which is called joggle machine. In the manufacturing industry, if you go and ask what is joggle machine, what happens is the plate is bent, the edge is bent like this. What happens? The shell, the one shell, the adjacent shell, it goes inside, so that here you do a weld here, Okay, this is also called type 2 welding, and only for circumferential joint. This is not applicable for long seam joint. That is when you roll the shell, it is not applicable for long seam, but for circumferential shape it is applicable. Okay. So type 3, it is single welded. In the back strip there is no welding done for me, or this back strip is not at all used. This is type 3. And type 4, the double lap joint. Same like, if you see here, it is almost same, but here what we do a fillet weld. We have a, you just increase the diameter of the shell so that it goes inside the next adjacent shell, and you do fillet weld here and fillet weld here. This is called double full fillet lap joint. And this overlapping is defined in UW. You go, you check corresponding as per different, depending upon the thickness, different thickness. It is given in the ASME section division 1 very clearly in UW, that how much lap it is required here. Normally what we do, depending upon thickness, we take 2 times of thickness, or we take 3 times of thickness for the overlapping, and we do fillet weld here and fillet weld here. Okay. So moving on to next type 5. So in type 5 we use plug weld. Okay. You have a shell here, it is shell over here, but you have a head, but here you put some plate and you plug it, just weld it thoroughly. Or you put a back strip, you put a strip over here, and you do weld it properly. So this category, this welding, which is not commonly used in a pressure vessel company. you know this type 1, type 2, type 3, and type 4 are most commonly used. Type 5 is not mostly used, and type 6 is also same. This overlap, but we have fillet weld. This single fillet, not double fillet. Okay. So depending upon the type of the welding, the efficiency of the weld has different it changes depending upon the type of weld. Means, it is called as RT1. So RT1 means, this category A, category B, all this will be completely completely tested with radiography test. And here what happens, the efficiency of your weld, it is increased to 1. Why 1? Because you have checked all the weld joint, right? So here it is RT1, and usually RT1 is used when the process inside the vessel is a lethal process, or lethal chemical, or very dangerous chemical to humankind. In that case, we use RT1. It also depends upon the client. Sometimes our client says, no, I want my vessel to be fully with no composition welding. That time also you can do RT1. Okay, but it is cost. It is having more cost than other radiography tests. So this is RT1. So here, if you see in the head, if you see here, if you have I've shown H. So the H in the picture categorize that no need to do radiography over here, because what happens with this joint are normally done in the ground position. Okay, because the welder have a very good efficiency of welding when he is welding in a ground position. That is what we say as a 1G welding. That is the bottom horizontal welding, or bottom, the plate is placed in the bottom and he's welding. So normally we don't do the radiography test here, but sometimes client says, yes, no, I want to do radiography here also. In that case, yes. So here, ND is, that's why I have seen the previous video also. The ND must be predefined by the client, because it depends where, if it is as per code requirement, if it's not, this is not required, but the client perceives, no, I want to have a radiography test here. So yes, you can go ahead and you can do radiography test over here also. But as per RT1, it is not required. Category A, category B joint, all the category A, category B joint will be full radiography. So this will be RT1. So RT2, which is called as the RT2, is combination of RT3 and RT1. Okay, so RT3 is spot radiography. I'll come to that. But before going into RT3, we need to say what is RT2. So RT2, it's a combination of RT1 and RT2. Okay, so RT1 is full radiography, correct? And RT2 is a spot radiography. So what happens here? this joint, if you see category A, in category A you will do full radiography, but in category B, this is also category A, okay, but this is circular seam, this is called long seam. In circular seam, you will do a spot radiography here and you will do spot radiography here, but you can take this efficiency as 1. You can take it as 1. That is the benefit of doing RT. It is less in cost, but it gives you good efficiency of welding, and that is why normally, when client says RT1 is, is very much costlier, I want to go to RT2. So RT2, what will happen? Your efficiency will increase, the thickness will come down. So and it is less expensive compared to RT1. So moving on to RT3, RT3 is spot radiography. It can be year, but the condition for spot radiography is if the welder has done welding to this complete vessel, if you have only one welder. So in that case, what will happen? In 15 meter, 1 5, or 50 feet, 50 feet, one spot will be sufficient enough to specify the welding efficiency. For example, this complete vessel, this is 2 meter, this is 3 meter. For example, I am saying, okay, this is 3 meter, this is 1.5 meter, this is again 3 meter. Okay, so what happens? 3 plus 1.5 is how much? 4.5, 4.5 plus 3 again 7.5. So you are complete in 7.5. So again 7.5. That means this is 15 meter. So complete in this complete welding, you need to have only one spot. Okay, so one spot is enough for 15 meter of welding. If your one welder has done the welding. If there is two welder, then you have to do two different spot depending upon the weld length. Okay. So here in this case, what we do, the efficiency become 0.85. So next is no radiography. Sometimes what happens, the client says, no, my pressure vessel is not so much lethal and it's not so much, pressurized. It is less pressure, maybe a 2 bar or 3 bar pressure. So, I don't want to have radiography, but I want to do just normal, what we say, the dye penetrant test. I don't want to have radiography test. Yes, it is allowed, but in that case, efficiency become 0.7. Okay. So moving on to next slide. Here, uh, there will be, you must be, confused, why radiography and what is the radiography requirement. Thickness, depending upon thickness in UCS 57. Here, P number is given depending upon the P number group number, and this is the minimum thickness. If your plate exceed this thickness for this group number, so what will happen? Your radiography it will be RT1. That is mandatory requirement. For example, you have pressure vessel where your plate is SA, that is it falls in P number 1. So it should not exceed 32 mm thickness of a plate. If it exceeds 32 mm, so what will happen? It will fall in the category of full radiography. Okay, this is mandatory. You cannot avoid it. And if you are going to this much group, 5A, 5B, 5C, and 15E, so your group used to see, if you use this plate, it is mandatory to have full radiography. Despite of thickness, whatever thickness you use 4 mm, 10 mm, 6 mm. So whatever you use, it has to go with the full radiography. So uh, that's it in today's video. I hope I have given sufficient information, and I hope you have got information about the radiography, what is different radiography, different type of weld joints, and what is the efficiency depending upon the radiography and weld joints. Why I have told you all this, because when I'm going to next part where I'll be teaching you, I'll be showing you the calculations or formulas that are this efficiency play a major role, and depending upon the efficiency, the thickness also get reduced or increased depending upon what kind of radiography you're using. Okay, I hope it is you have got sufficient information. So thank you. Please don't forget to like, share, and subscribe to my channel. Thank you. Bye bye. Take care.